Right? Am I right? All right. Congratulations, made it to databases. Yay! So this is sort of the last key in what we're going to be calling our full stack. Up till now, you've worked with front end, you've worked with server side, and then you've made requests to like JSON files, or we've worked with it. Database is basically the last thing we're going to do. So I'm going to actually show this here. This is Q1, right? Or this is up until now. This is, we have our like browser, server side, server, and then up to them we sort of have JSON files, and we've made requests back and forth. Now we're at the point where we're doing those things, but we're doing it with like dynamic, complex systems like database servers. So storing all our information here, and that's full stack. That's it. It's kind of a crappy graph. So this week we're really talking about this, and yeah. But before we kind of dive into database, we really need to talk about, like, you need to have sort of understanding of how it works. So there's going to be like data informations, tables, entities, rows, stuff like that. So that's what this lecture is all about. So what is a database? It's a way to store and organize and retrieve all things. So we store persistent data. We don't just store static objects in JSON files. We store persistent data that we can update, read, delete. We have all this access to it. Before we begin, I'm going to give you some objectives. So by the end of this lesson, you should be able to explain the difference between data and information, explain what an entity is, define and describe data management systems, and why we use it. Also describe and store a relational database using terms like table, field, and record, and define primary and foreign keys. So what is data? Someone give me an example of data.
Bits of information.
Bits of information, love it. Facts. Others.
Sets of information.
Yes, sets of information, perfect. So we have data. Data has like, it's just basically facts, right? We don't know where it goes, we just know it's facts. What's the difference between data and information?
Information is a compilation of data.
Sure.
So, like, information is data is like all the facts disorganized, and information is like a compilation of all those facts that relate to one subject that create like a truth.
Absolutely. So it gives like data storage a home. Like say I just have a list of numbers. Like if I go, let's open up something. So like in JavaScript, for example, if I just have like 1, Aaron, 32, true. I mean, we have, we can have all this information. This is data. This is what data looks like. A lot of you probably know what this is, but I'm still going to show you. Information gives it like context, like a home. So if I said, hey, my ID is 1, let's see, like basically like a key, what we call them in JavaScript, like a key. Name is Aaron. So on and so forth. Age, I don't have to do this whole thing. And hungry, true. That's information. That's the difference between data information. It's definitely you need to know this before we move forward. Cool. So yeah, information with context. So a person has all these things, whereas data is just stored facts. So what's an entity? I heard it.
An object?
Yes. Right. So if I were to go back to my JavaScript and I said Aaron, well, say Aaron equals object, stored all this information in here, that's an entity. So it's like an instance. So if I had a table, which we get in a second, we have rows, which is basically like individual entities, and then we have, or fields, and then we have columns, which is attributes. That's an entity. So if we have like students, for example, a table of students, one student would be an entity. So it's information with context, or yeah, with like stored in a person. Awesome. Cool. So what's a database?
The database is a container, a storage container for like any amount of data.
Exactly. So basically, just like a store, it's like a bucket of just data tables. That's what we use from, we draw from. Cool. Yeah. It's a structured way to easily search and access information in the future. So database is where we can basically store all our tables. We grab, each table has a certain entity, has certain information, and we can start sorting that. Where we hold our tables. Good. Moving on to this one. Now you probably start. This is probably something that you haven't really covered yet, but data management system. What is a data management system? I mean, I'm gonna give you guys like 2 minutes to look up a data management system, and then we're gonna turn to each other and give you another minute to talk about it, and I'm gonna bring that up here. So look up, what is a data management system? All right, I'll give you 1 minute. Turn and talk to your neighbor and discuss what a data management system is.
I'll compare it
All right, I'm just gonna cold call someone. Yeah, you know what? I like that. Wes, what's a data management system?
So what I saw is it's kind of the software that you use to actually be able to interact with the database, so you can read, you can write, you can update
Perfect.
information.
Exactly. Yeah, that's awesome. Yeah, basically, management system is you can read, write, update, delete, manage, manipulate, all things. It's pretty cool stuff. Let's see. I want one more. Let's see. Jason, this is true. What's a DMS?
What's a DMS? Right there on the slide, just efficient, reliable, convenient, safe.
Oh, perfect. Look at that, right? Like perfect.
An example of that this could be like Postgres, SQL, right?
Great.
MySQL, example of that as well.
Right. Cool. Yeah, basically that. Efficient, reliable, convenient way, safe to multi-user, so multi-user can use it. It's reliable, secure. Uh, uh, Basically, think of it as like you have a bookshelf and there's a ton of books on there. And in order to update stuff, you would, if without a data management system, you'd have to literally go in there, or let's say they're files. You have to go in there, look through every single file, and manually and try to update yourself. Data management systems using queries can go in there, do it safely, effectively, and conveniently. So stuff like Postgres is a data management system. Oracle, MySQL, NoSQL, all those are data management systems. Cool. Yes, they're huge, massive. Tons of data. It's a way to store tons and tons of data, especially if you have like a large organization, say a bank, government, anything like that. Data management systems used for that. Persistent, safe, multi-user. I just went over. Already went over it. So. Cool. So yeah, who uses data management systems? Who do you, off the top of your head, who do you think uses data management systems? I just gave you a few examples. Researchers, awesome. Over there, who uses data management systems? Kyle. Bank. Yeah. U.S. government. Unfortunately. Jonathan, give me like an example of like a data management system or a company that uses it.
Say that again.
Give me an example of like an organization that uses data management system. Walmart, yeah, unfortunately that too. These are all really unfortunate examples. Yeah. So what type of information do they need to store? Never mind. Okay. So when we're working with servers, we have our browser server, we have our front-end server, generally we have like a node server where we're storing, making requests to the database, and then we have the database server. None of these servers. Basically, database servers and regular servers are different ones. Node server and databases are completely separate things. So when we're building our full stack application, we're actually dealing with 3 servers. And it's what we use, those servers are what we use our database management systems and how we run it and administer it. Cool, so let's get into the nitty-gritty of data stored. If you already know this, okay, don't pay attention, but data is stored in tables, and they're 2-dimensional tables. Each table has basically a columns, which we call we call fields, and they all store attributes. So this one example, we have name, email, GitHub, and then we have rows, which are records, and these are also entities. So Zach Smith, email here, GitHub here, and his cohort ID. Those are all entities. So data is really cool for being organized, but it can only store a couple of things. So we can only store like numerical data types. We can only store characters, binary, dates. That's why we're going to get into relational databases, because these type of databases can't store arrays. They can't store objects, and that's what we're going to be doing with pSQL. We're going to be doing relational databases. So what is a relational database? I'm going to give you 1 minute to Google it, and then turn and discuss with a partner. So what is a relational database? All right. I want you to turn to someone you haven't talked to and discuss what a relational database is. Except for that table over there. Looks like you got to talk to each other again.
Talk to me, man.
What is
What is it?
It's pretty similar from
I call it a database. It's a database structure to recognize relations, store items, information. Okay.
All right. Everybody, give me, let's see, I'm going to call on one person, two people. Moira, what is a relation database?
It's a database structured to demonstrate relations between information.
Absolutely, perfect example. Let me get one more. Let's see, James. James, what is a relational database?
I think more is the whisper.
Yeah, it was. What does it mean to you?
What is a relational database system usually look?
So would it be something like Excel when you reference different tabs?
Yeah, I mean, similar.
From one tab on
Yeah, no, well, okay, so relational database is basically you have multiple tables, right? You have one table that stores students, another table that has cohorts, and each of those tables and each of those entities, there's like a specific unique ID. So each row has a specific ID. So say I have students, so one cohort can have many students. So basically when I'm looking at my students here, I say, okay, in each entity, I'm going to reference that ID for another one. So that was not such a good example. So really, we were talking about relationships between tables. So because we can't store arrays and objects in a table, we're going to have to do this this way. So for example, we have cohorts, and each one of those cohorts has an ID. So let's just say a unique ID. And that's about it. Cohort has a unique ID. And then here we have students. Each student has a unique ID. How are they going to talk to each other? And how are we going to know that this student has a specific cohort? So that's where we have relational data. So when I want to reference to my students, because I know that each cohort has multiple students, I'm going to reference this ID. And this ID carries in all this information here. Just like the cohort ID. Does that make sense? It doesn't make sense yet. It will. Basically, it's like we're trying to find a relationship. So we know that because there are many students in a cohort, but there's probably one student per cohort, we need to reference this cohort here. So this is like an array. This is like an array of students, and this is a cohort. So that's how we're doing. Yes?
So is the cohort like a primary key and the students would be a foreign key?
Yeah, similar. So every single table has a primary key right here. And foreign key could be basically this is the FK. When we're pulling in this foreign key, I'm referencing this primary key from this table. So what's a relational database? A collection of table of which are we can describe and organize a relational model. Each table must identify a column or group of columns called primary key. So as you can say, each table has a key, and each row will have its own unique key that you can reference. So instead of like having to reference every single student in cohort, you can just call their primary key or primary ID. Cool. So going into primary key. Primary key is a unique specific column within a table. All primary keys are unique and cannot be like repeated. So again, every table has a primary key, and it's specific to that specific entity. So if you go back to this example here, see here, and so most databases will be like this, and non-relational databases will be like this. When we have a ID, if instead of referencing every single thing in here, this array of attributes, I only need to reference this in the next table. And once I reference 802 in the other table, then I have information for all of these.
So does that mean that in the where we have the word ID, so probably we have a number there that will reference the whole thing?
Yeah.
That table.
And generally, when we set up relational databases, these unique when we have to set up our databases and list the types. You know, the names would have to be text or character. Numbers would have to just be a numerical, data type. When we set up IDs, those database management systems will set up individual IDs for you under the hood. So that's a really cool thing to have.
Actually, I think they have it here. Core ID.
Yeah.
32, so that's what we have.
So this is the foreign key of cohort ID. So if I had a separate table over here called cohort, and I reference an ID, or we're saying, hey, this is ID, this is cohort 32, I'm referencing that one. Okay. I might have lost you guys there. It's going back. Yeah. Again, here's sort of a primary foreign keys, way better than my setup over here. First of all, we have looks like a student table, and it's referencing a foreign key, which actually comes to be this ID right here. And then here, this ID, we have specific things that we want to reference. So this is like ID of g59, and this is the ID of 18. So now we know that this cohort has multiple students, and all those students are referencing from cohort ID 32. Okay, I'm going to do a show of hands in terms of understanding. Like from 1 to 5, 0 being like, I don't understand what the hell you're talking about, to 5, just show me. Oh, okay. All right. Sweet. Cool. All right. So let's go into this exercise. Think about a relationship of two objects. They would have a primary key and a foreign key, and draw the relationship using a table with like proper column ID. So Eddie, can you cast me those? I have to share. What's up, kid?
So, is this what you're talking about here? Like,
Sorry, I'm shitty teacher.
no, what's up? Is this the relationship you're talking about?
Yeah.
Sort of?
Yes.
Okay.
I mean, it's not. So what happens is in each table you have a. Actually, hold on. Let me.